Okay, so let's dive right in. We only have a short amount of time. So what I'm going to give you is first the roadmap of the brief talk I'm going to give you. So I'm going to talk to you about the problem that I'll be addressing and some of the causes of that problem or those problems, consequences, and solutions. So a lot to cover in 15 minutes, and I'll just touch on these issues, concentrating a little more on a few that I think I'm particularly interested in and hope you're interested in. So let's start with the problem. So the problem I'm talking about is first a problem of sperm decline. And you may remember, some of you, that a long time ago, back in 1992, 40 years ago, there was a paper that came out of Denmark, which was very impactful, that claimed that there'd been a genuine decline in semen quality over the past 50 years. On this slide, you can see that back there in, I think it was 38, the sperm count was 113 million per milliliter. And at the end of the study period, I can't get rid of my bar there we go. At the end of the study period, it was 66. So that is a drop of close to 50% in those 50 years. So I was intrigued, possibly alarmed, curious, and skeptical about this paper. And I spent actually first 6 years trying to make it go away and could not move this slope at all at the first decimal place, and then went on to doing other analyses that might lead to different results, considering different confounders, different factors, how the sperms were counted, how the men were included. Nothing really seemed to make a difference. And so I began to take it seriously, as did other people. So between then and this slide that I'm going to show you now, which is in 2017, this field grew tremendously, and we learned how to do these systematic reviews much better. We learned what factors we might consider. And what I want you to see here is that the slope that we published, and this is from the 2017 Levine et al. Paper, that came out and went really viral when we published it, the slope is really pretty similar. And we had a sperm concentration of 99 million per milliliter back in 73, so we didn't go as far back. And we went further forward to 2011. One difference is that we reported the year of sample collection, whereas Carlson had the year of publication. So that's another difference. But what's very, very similar is this isn't going away. This isn't going away. And so I want to point out that the 52% decline now is a little faster than 1% per year. At the bottom of this curve, you see some dotted lines. I'm asked many times, what happens when we hit zero? Just want to quickly say, this curve cannot hit zero. Okay, let me read it right. This curve cannot hit zero. It's a logical impossibility because these are mean sperm counts, and that would mean that a substantial number of sperm counts would be negative, which is not possible. Okay, so what can happen? We can come closer and closer to zero. It's called an asymptote. You reach it at infinity, but short of infinity, we can come closer, or possibly the curve can turn around. And so that's what we're waiting to see, what's happening with this. But even 47 million per milliliter is a pretty low sperm count. It's basically men's sperm count over this 39 years has been cut in half. It's not just sperm count that's at issue. On the male side, we have other properties of sperm, such as their form, their morphology, their motion. We also have the question of smaller genitals, which I'm going to spend a little time on today. Reductions in testosterone, which are extremely important and have implications for libido and erectile dysfunction and so on. We have genital defects of the male. And on the female side, we have many issues that are less studied, primarily because female physiology, reproductive physiology, is much less visible and accessible. You can count sperm, it's very much harder to count eggs. So, and in the center, let's not forget that there are many things that are shared between male and females. Infertility is not really a male or female problem per se, it's a couple problem. Both have ambiguous genitalia, hormonal abnormalities, low libido, and failure of assisted reproduction is a growing concern. So, given this huge range of problems, what can we say about causes? So, just very briefly, I want to point out that this change of 50% in 50 years, 2 generations, a drop in half in these endpoints is not going to be genetic. It's too fast. So, if it's not genetic, then it's going to be environmental. And the environmental lifestyle factors are important, but not what I'm going to talk about today, because we're talking about food packaging. Just to mention briefly, those might be things like obesity, smoking, binge drinking, lack of exercise, and so on and so forth. Diet, important. But I am going to focus on the chemical exposures and particularly the endocrine disrupting chemicals, because reproduction, of course, depends heavily on reproductive hormones, and those are what I'm going to be focusing on. So before I go to any specific one of these chemicals, I just want to give you this array, which I'm sure you're all aware of, but just point out that these are chemicals, everyday, everywhere chemicals that we're used to, that we're barraged with, and Teflon and rubber duckies with phthalates and flame retardants and pesticides being sprayed and bisphenol A in tin cans, cosmetics that we lead us to the conclusion, and as measured by the CDC, these are in everybody at pretty high doses in the hundreds, okay? So now let's focus on one class of these. And these are the class that I focused on ever since a colleague suggested to me that I do that. John Brock from CDC said, Shanna, you should study phthalates, and I'd never heard of them. And I began to study about them. And what I learned was, first of all, that this picture on the left showing the rise in testosterone in a pretty narrow window of gestation is completely wiped out when the mother, this is a rodent, is exposed to, in this case, diethyl hexyl phthalate. So, and nothing, by the way, nothing much happening to the female. So this is pretty dramatic, and we have to ask, is this important? Does it matter that this testosterone surge is reduced at this time? And the answer is yes. In this schematic, we see on the left the undifferentiated sex organs, and when that testosterone is not present, the genitals develop in the female typical way, genetic female, and in the presence of testosterone, they become masculinized. This is a crude, simple, comic, if you will, cartoon, but I think it makes the point that we really need testosterone in the male to develop in the male typical manner. And what happens then if the phthalate is reducing that testosterone in that critical window? So in 2005, Paul Foster and Earl Gray actually showed that there was a whole suite of endpoints which were affected when this happened, when phthalates were introduced in the critical window, and then the male was altered in a way that they named the phthalate syndrome. Now, I just want to take a minute to say this is kind of important because there's not too many syndromes named after chemicals. There's fetal alcohol syndrome, but we don't see many other syndromes. And I think this is testimony to the importance of this syndrome, which includes, among other things, smaller penis, a malformed penis, undescended testicles, and for me, very importantly, shortened anogenital distance. So the anogenital distance is a measure that has been used in toxicology for quite a long time. It was actually known back in the beginning of the In 1905, there was a paper showing that male and female AGD was different, that males had about 50 to 100% longer AGD. And so this was a marker of reproductive toxicity by the NTP and other programs. And this syndrome, when I saw this, I said, wait a minute, okay, CDC said we're exposed to these phthalates. People are, that pregnant women are. What's happening on the other end? Could we look at this? And so we asked this question: if the mother is exposed to phthalates, we didn't know too much about the timing at that point, and does that result in these changes in the baby? So we spent quite a lot of time trying to figure out what would you look at in a baby, since this syndrome had not been looked at in relation as a toxicological marker in humans until that time. And so we kind of copied the animal study. I talked to the toxicologist about how they did that. I talked to pediatricians, what do they look for? And we ended up with this exam. And we fortunately had a population for whom I had stored urine. Not sure why I would use it, but I had it there. Pregnancy urine, sent it to the CDC, got phthalates measured, got the babies brought back in, measured these distances and sizes, and we found the phthalate syndrome. So this first paper was published in 2005, and we did announce that there was the shortened intergenital distance. We didn't call it the phthalate syndrome at that time in humans. And then, of course, because you have to do this, we replicated this all again. And so the second time we did it, I think, quite a bit better. We got timed urines early in the first trimester. We examined the babies when they were born, just as the animals are. And we had other sort of more careful measurements, but we found the same thing. So we did see a phthalate syndrome in 2 human studies. And this has been now shown in many other human and, of course, animal studies. Sorry. So I want to point out here the importance of timing of this exposure, and this will be true of other endocrine disrupting exposures. Timing is actually really, really critical, so that when studies are done for an endpoint where you measure in an adult, but the damage was done in utero, you're just completely off the mark, aren't you? Because unless it's a persistent chemical, which phthalates and phenols are not, you're not going to have any information about exposure in the critical window. So here's one example of how this can go wrong. And this is not this is smoking, which does contain EDCs, but it's of course much more than that. This is from Denmark, these data from several studies. If the man is smoking around the time of conception, and male-mediated effects are often overlooked, by the way, because it's always the mother that's responsible. But in fact, in the 70 days that the sperm is being produced that's going to conceive that conceptus, he can introduce exposures that will affect development. And in this study, when the man smoked around that time, then the son had a 40% reduction in sperm count. When the mother smoked in early pregnancy, the son also had a 40% reduction in sperm count. Parents did not. Then his reduction was only 20%. But here's the kicker: he can stop smoking and recover his sperm count. The damage done in utero will not be recovered. So what are some of the consequences of this damage? Well, one thing that's only more recently known is that the sperm count is actually related to the AGD. So when the AGD is shortened, as we showed in connection to phthalates, then sperm concentration is also reduced. This is important because it ties together the phthalate AGD work with the sperm decline work, and shows, I think, that phthalates are in part responsible for the decrease in sperm count. Michael Eisenberg also showed that this AGD is also related to fertility. What are some other consequences? Well, there's a surprising consequence for some people that men with low sperm count have higher morbidity. They have higher rates of heart disease, diabetes, reproductive cancers, and actually they die sooner. They have a shorter life expectancy. And this is true whether or not they had a child, but it's more marked in men with low sperm count who never had a child. So it's actually a measure of overall health, if you will. And finally, I want to mention that the exposure to the mother doesn't stop with the mother. We know, of course, from this discussion that it does affect the fetus, but within that fetus, I think most people on this forum know that the fetus is carrying the germ cells for what will be the egg and sperm in the next generation. And so those are also affected. And there are many studies suggesting that this is going on for further generations. So we're looking at exposures that are going to have lifelong impacts for the individual affected, his children, and certainly his grandchildren or her grandchildren. And so I want to just quickly summarize some of the solutions that I think have to happen in order to turn this around. So we have to remove the chemicals that are hormonally active. A huge job that many of you are working on. And now we know it's not just the chemicals, but their products and their breakdown products of every size. We need to remove those that cause harm at low doses. And this is an area that Chris Portier was talking about to some extent, but I think we need to recognize that hormones are active at extremely low doses. We see that in the testosterone transfer across same-sex fetuses in the womb in rodent studies. And we see the effects of low doses, for example, in tamoxifen. This is a whole area of discussion, but I just want to mention that we have to keep this on our radar. We have to remove chemicals that are environmentally persistent. And finally, we have to look at those thousands of untested chemicals that were just grandfathered in and never examined for safety.
Shanna, time is not on our side today, so I'd like to ask you, it's so interesting, but we want to have a bit of time for the discussion.
No, I have 2 slides, right?
Okay, great, thanks.
Thank you. And we have to introduce chemicals without EDC effects, free of low dose adverse effects, and minimal environmental persistence. And finally, safe prior to marketing. And we do this by assessing low doses, mixture effects, environmental persistence, and risks in untested chemicals. So that's all I have today. Thank you for your time, and we'll have a question period later.